Hello everyone, this is Dr. Hopkins with our next video. Here we're going to learn how to balance redox reactions. It may seem kind of a simple concept, and maybe most of you have done this before, but the one thing about redox reactions is it's not so easy to do it by inspection. But we're going to take advantage of the fact that we're in aqueous solution, and what is the solution, whether it's acidic or basic, and what can be present and what can't to balance a reaction. So we'll start out with, we'll start out with the unbalanced net ionic equation. So we're going to get rid of any of the spectator ions. Those we just don't care about in a redox reaction. And then what we're going to do is we're going to split it into two half reactions. So one will be the oxidation half. So whatever is undergoing oxidation, the reactant in the product goes in that reaction, and a reduction half reaction. So we'll write two unbalanced half reactions. So we'll split it out and we're going to balance two reactions and then join them together in the end. And then we're going to balance each of these half reactions for all of the atoms that are not oxygen and hydrogen, so any metals and so forth. And then once we've done that, we can then balance each half reaction for oxygen by adding water to the side with less oxygens. So we're adding the oxygen from the water to balance that. And you need to do this in the right order, because then we're going to balance for hydrogen by adding protons to the side of the reaction with less hydrogen. So because we're assuming that we have free protons available, we can just add them in. And then we're going to, at this point, we should be balanced for mass. All right, so we should have all of our atoms balanced, but we also need to balance for charge. And we're going to add electrons to the side that's more positive until it's balanced on both sides. And that's for each of the half reactions. And then at that point, we need to make sure that the number of electrons in the reduction half and the number of electrons in the oxidation half are the same. So if they aren't, we need to multiply these half reactions by a number in order to make sure that the electrons cancel. Because in the end, we don't have any free electrons in our reactions. And then we're going to add them together, cancel the electrons, cancel any species, so say waters or protons that end up on both sides, and then sum up, and that would be our balanced reaction. That's where we stop if this reaction is run in an acidic solution, so under acidic conditions. If it's in basic conditions, you can't have free protons, because in basic we should have free hydroxides. So the way you do is you balance for acidic, and then there's another step where you add OH minus, so hydroxide, to both sides of the equation. That way we're not unbalancing our mass in order to neutralize the H pluses into water. Then you sum up and cancel any waters that are on both sides and so forth, and you have the balance reaction. Okay, so those are the rules. It's probably easier to see how to do this if we show an example. So let's balance the following net ionic equation. All right, so now we have our net ionic equation set up, and the first step is to split it into half reactions. Now, most of the time, it's pretty obvious what you're going to split into half reactions. So you don't really have to use our oxidation numbers to figure out what's being oxidized and what's being reduced. But if we were to do that, we would notice that this is a +6, this is +3, this is -1, and then the I here is a +5. So this is our oxidation, and this is our reduction. So that's oxidation, and that's our reduction. But most of the time, you'll notice you have the I minus on one side. It's going to generate IO3 minus. The I minus doesn't just convert into chromium. Okay, so we start with our two half reactions. So we split them up, and now we want to balance them for everything but oxygen and hydrogen. If we look at the first one, and the only thing we have there is I, and there's one I on both sides, so that's balanced. This one we have dichromate, so Cr2O7, and we only have one chromium on this side, so let's put a 2 over here. Okay, so that's the first step. Now we need to balance both sides for oxygen. Okay, so if we look at the top half reaction, we've got 3 oxygens here. We have none over there, so we're going to add 3 waters to this. Okay, so that way we have 3 oxygens here, 3 oxygens there, and that's good. And then we're going to add, so we have 7 on this side, none on this side, so we'll add 7 waters on that side. Okay. Now we've balanced for oxygen, we've balanced for everything other than oxygen and hydrogen. Let's balance for hydrogen. So we've got, this side has, this IO3 minus side has no hydrogen. We have 3 H2Os, so that's 6 hydrogen, so I would add 6 H plus on that side. This, on the dichromate side, we have no hydrogen. And on the other side, we have 14, so we would add 14 protons to that side. Okay, at this point, we're mass balanced, but we need to balance for charge. Okay, so let's take this top equation here. We have what, 1 minus, we have 1 minus and 6 plus, so that would be 5 plus on that side, right? Or excuse me, yes, 5 plus and 1 minus. So we can only add electrons, so we would add 6 electrons to this side. And then that would be, so plus 6 minus equals minus, and both sides are balanced for charge. Now if we look at the next one, here this is 2 minus plus 14 plus, so that's 12 plus. And then this one is 6 plus. So we would add, and you may not be able to see this, 6 electrons to that side. So now we have both of them balanced for charge. Now the next thing to check is, hey, are the electrons the same? And actually it's important to know, if your electrons are on the same side of the equation, you've got something wrong. But we've got electrons, we've got 6 electrons on this side, we've got 6 electrons here, so we don't have to multiply either one of them by anything. We can just add this together and cancel everything that ends up on both sides. So that means the 6 electrons go away. We get Cr2O7 2 minus. We get 1 I minus. We have 3 waters, which are going to go away over here. We got 4 over here. And then, so I don't have any water. That's going to translate. We got 14 H pluses and 6 that'll go away from that side. So this is 8. So it would be plus 8 H pluses. And then we end up with 1 IO3 minus plus 2 CR3 pluses plus 4 H2Os. Okay, so now what we want to do is we want to check, make sure we write everything correctly. We want to make sure that everything's balanced for charge and mass. So this should be a balanced reaction. So we've got 2 chromiums, 1 I. We've got 7 oxygens. We've got 3, 7 over on this side. That's good. We've got 8 hydrogens on this, so we've got 8 hydrogens. And then the total charge here is 3 minus 5 plus, right? So we got 8 plus 3 minus is 5 plus. And then this is a 3 plus. So this is 6 plus, 1 minus, 5 plus. So 5 plus, 5 plus, we are balanced. Okay, now what would we do if we wanted to balance for basic? So if we wanted to change this in a basic solution. Now this reaction wouldn't happen in basic, but if we wanted to balance this for basic, we've got 8 H pluses on this, so we would add 8 OH minuses and 8 OH minuses to both sides. And so then these 8 would generate, so we would end up, I'm going to write an intermediate here because it's getting kind of messy. I minus plus 8 waters. Remember, that's what a neutralization reaction results in. We got IO3 minus. We got 2 chromiums. We've got 4 waters, and I don't have enough room. And we've got OH minus, so 8 hydroxides. Now those 4 waters are going to go away, and we'll be left with 4 on that side. And so then our final balanced reaction is Cr2O7 2 minus plus I minus plus 4 waters is IO3 minus plus 2 chromium plus 8OH minus. That would be balanced in basic. So this is, above was balanced in acidic. We added the extra step, balanced in basic. Now that you've seen how to balance, or seen an example of how to balance a redox reaction, the easiest way to learn is by practicing. But basically, this whole video was just about that process. And it's not a simple inspection, add numbers to both sides, and you can get it right. You have to follow the steps in order. Otherwise, you won't get a properly balanced redox reaction. So until next time.